Hello everyone. In this tutorial we are going to discuss the introduction of UML, the basic things used in UML, as well as what is modeling language, what is UML, why should we use UML, the history of UML, its design, and the different diagrams used in UML. Now, coming to the first, that what is UML. um, the full form of UML is Unified Modeling Language. The Unified Modeling Language is a general purpose developmental modeling language in the field of software engineering that is intended to provide a standard way to visualize the design of a system. The creation of UML was originally motivated by the desire to standardize the disparate national systems and approaches to software design. It was developed by Grady Bush, Ivar Jacobson, and James Ramba at Rational Software in 1994 to 1995, with further development led by them through 1996. In 1997, UML was adopted as standard by the Object Management Group, or OMG, and has been managed by this organization ever since. In 2005, UML was also published by the International Organization for Standardization, that is ISO, as an approved ISO standard. Since then, the standard has been periodically revised to cover the latest revision of UML. Now, uh, coming to the modeling part, uh, first, as I told you, unified UML is unified modeling language. So let us first check what is modeling language. A modeling language is any artificial language that can be used to express information, knowledge, or systems in a structure that is defined by a consistent set of rules. The rules are used for interpretation of the meaning of components in a structure. It is used for describing a system at a very high level of abstraction. Uh, it is a model of the um, main system, and it is used for requirements and specifications. A modeling language can be graphical or textual. Graphical modeling language use a diagram technique with named symbols that represent concepts and lines that connect the symbols and represent relationships and various other graphical notation to represent constraints. Textual modeling languages, on the other hand, may use standardized keywords accompanied by parameters or natural language terms and phrases to make computer interpretable expressions. Now, it is important to distinguish between the UML model and the set of diagrams of a system. A diagram is a partial graphic representation of a system's model. The set of diagrams need not completely cover the model, and deleting a diagram does not change the model. The model may also contain documentation that drives the model elements and diagrams, such as written use cases. UML diagrams represent two different views of a system model: static or structural view and dynamic or behavioral view. We'll go for a detailed discussion regarding this later. Now, let us discuss what is UML. As we know, UML stands for Unified Modeling Language. It is a industry standard graphical language for specifying, visualizing, constructing, and documenting the artifacts of software systems. The UML uses mostly graphical notations to express the object-oriented analysis and design of a software projects software projects. It simplifies the complex process of software design. Obviously, if we go for graphical representation of a system, obviously it will be easy to understand, and it is as it will be easy to understand, the design will be easy. Or if the design will be easy, then the coding of that design will be easy. Again, the testing of that coding will also be easy, so it will be easy to maintain. The system will be easy to maintain. Now, why should we use UML? UML graphical notation, notation to it's a use it use graphical notation to communicate more clearly than natural language, imprecise and code that is too detailed. It helps to acquire an overall view of a system. UML is not dependent on any one language or technology. This is very very important. This will come may come this may come like MCQ. Okay. Again, UML moves us from fragmentation to standardization. Okay, so it is very this third one is a very commonly asked question in the exam, like as a form of MCQ. Okay. Next, coming to the history of UML, uh, we can see the picture of the various transformation of UML versions. Now, under the technical leadership of Ramba, Jacobson, and Bush, a consortium called the UML Partners was organized in 1996 to complete the Unified Modeling Language specification and propose it to the Object Management Group or OMG for standardization. The partnership also contained additional interested parties, for example, HP, DEC, IBM, and Microsoft. The UML Partners UML 1.0 draft was proposed to the OMG in January 1997 by the consortium. During the same month, the UML Partners formed a group designed to define the exact meaning of language constructs, chaired by Chris Corbin and administered by Ed Ecole, to finalize the specification and integrate it with other standardization efforts. The result of this work, UML 1.1, was submitted to the OMG in August 1997 and adopted by the OMG in November 1997. After the first release, a task force was formed to improve the language, which released several minor versions like 1.3, 1.4, and 1.5. The standards it produces, as well as the original standard, have been noted as being ambiguous and inconsistent. So we have got then UML 2. UML 2.0 major division replaced version 1.5 in 2005, which was developed with an enlarged consortium to improve the language further to reflect new experience on uses of its features. Although UML 2.1 was never released as a formal specification, versions 2.1.1 and 2.1.2 appeared in 2007, followed by UML 2.2 in February 2009. UML 2.3 was formally released in May 2010. UML 2.4.1 was formally released in August 2011. UML 2.5 was released in October 2012 as an in-progress version and was officially released in June 2015. Formal version 2.5.1 was adopted in December 2017. There are four parts to the UML 2.x specification: the superstructure that defines the notation and semantics for diagrams and their model elements, the infrastructure that defines the core metamodel on which the superstructure is based. The constraint language OCL for defining rules for model elements. The UML diagram interchange that defines how UML2 diagram layouts are exchanged. Until UML 2.4.1, the latest versions of these standards were UML superstructure version 2.4.1, UML infrastructure version 2.4.1, OCL version 2.3.1, UML diagram interchange version 1.0. Since version 2.5, the UML specification has been simplified without superstructure and infrastructure, and the latest version of these standards are now UML specification 2.5.1 and OCL version 2.4. It continues to be updated and improved by the revision task force, who resolve any issues with the language. Now, coming to the design, UML offers a way to visualize a system's architectural blueprints in a diagram, including elements such as different activities or jobs, individual components of systems, and how they can interact with other software components, how the system will run, how entities interact with others like components and interfaces, external user interface. Although originally intended for object-oriented design documentation, UML has been extended to a larger set of design documentation as listed above and has been found useful in many contexts. Now, there are various types of diagrams in UML, which are divided into mainly two categories. Some type represents structural information and the rest represent general types of behavior, including a few that represent different aspects of interactions. These diagrams can be categorized hierarchically as shown in the given diagram. Okay, so it is behavioral diagram, structure diagram, interaction diagram. Behavioral diagrams are have the types activity diagram, state machine diagram, use case diagram. Then interaction diagram with communication diagram, interaction overview diagram, sequence diagram, and timing diagram. Whereas in the structure diagram, it can be divided into a few parts like composite structure diagram, class diagram, deployment diagram, component diagram, object diagram, package diagram, and profile diagram. Now, we have seen various diagrams we have in UML, but as per the syllabus of graduation and undergraduation, graduation level or post-graduation level, like BTech, CSE, IT, or MCA, or MTech, or BCA, or BSc Computer Science, or MSc Computer Science, this mentioned diagrams are mostly used, and the most questions asked from these diagrams only, and those are use case diagram, class diagram, sequence diagram, collaboration diagram, state diagram, or state chart diagram. As you have seen in the previous slide, that this is only a subset of diagrams that are most widely used. In our next tutorials, we'll we'll discuss all these diagrams one by one. Okay, now these references I have used, I have found these very good, and if you want to check more on UML, just go through these links. So if you have any question, you can comment in the comment section. I'll try to answer. And for more videos, just subscribe the channel or click on the bell icon. So thank you. That's all for this tutorial. I hope you will understand this topic. Thank you.